Hello everyone, here we are on section 2 of unit 5 where we will be covering some information about mid-segment triangles and triangle inequalities. First we have this example here, so it says to plot the points A at negative 8, 2, B at 4, 8, and C at 0, negative 6. I've already done that part. And then there's a few questions that need to be solved below talking about midpoints and the distance of our segments. So I'd like you to go ahead and pause the video and work on those, and we'll pick back up when you are done. Alright, at this point you should have already finished those questions below, and this is what you should be seeing in your graph. You have the midpoints that we found. We connected the midpoints, and then we found the lengths of all of our sides. And our side lengths are already up here. I'm going to quickly review the steps on how we got all those things. So starting with finding the midpoints, we have this midpoint formula. So I have AB is equal to, or the midpoint of AB is equal to x1 plus x2 divided by 2, comma y1 plus y2 divided by 2, and that gives us the point negative 2, 5, and we did that for all 3 points, where x's and y's are coming from our end points of our segments. Next, after we found the midpoints, we needed to find the lengths of the segments. I'm going to zoom in here. So we have AB is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared, and that gives you a simplified down to 13.4 for our length of AB. All those measurements are already on our triangle up here, so we're going to take a look at some things that we can observe. So looking at this triangle, I'm noticing that I have sets of parallel lines. I have AC is parallel to EF, I have AB is parallel to DF, and I have BC is parallel to ED. The other thing I'm noticing, if you look at this, 7.3 times 2 is equal to 14.6, and those ones were parallel. And 5.7 times 2 is equal to 11.4, and those lines were parallel. And AB is 13.4, and DF is 6.7, and those are parallel. 6.7 times 2 is 13.4. So I'm noticing that we have sets of parallel lines, and the segments that go from the midpoints are half of the length of its opposite parallel side. And we'll come back to that in just a moment. Before we do that, we're going to scroll down here, because that triangle, that orange triangle we just drew, that's what we call a triangle, or a mid-segment triangle. A mid-segment of a triangle is a segment that joins the mid-segments of 2 sides of the triangle. Every triangle has 3 mid-segments, which form the mid-segment triangle. So those orange segments were the mid-segments, because they connected the midpoints of our triangle. And when you connect all 3 of those, the orange triangle is what we call the mid-segment triangle, where the purple triangle was our original triangle. Alright, so in this image here, that would be the red is our mid-segment triangle, and the black is our original triangle. And I know it's a mid-segment triangle because the endpoints are at exactly the middle of each of the original triangle's segments. And I know that because of the tick marks. Alright, so it is asking me to find some things here. First it says to label all the mid-segments, or to identify the mid-segments. Well, those are the lengths that travel from midpoint to midpoint. So I have XY, YZ, and ZX. So I'm going to write those out. I have XY, YZ, and ZX. And then my mid-segment triangle is just the triangle that's formed from those 3 segments. So I have triangle X, Y, Z. Alright, let's go ahead and flip the page where we will move on to our triangle mid-segment theorem. And this is actually getting at a few of the pieces that I was pointing out before in our example. So I said that we are noticing some parallel sides and something that was happening with them, where the parallel mid-segment was half the length of the triangle side that it was parallel with. And the triangle mid-segment theorem says a mid-segment of a triangle is parallel to a side of the triangle, and its length is half the length of that side. So if you notice in the picture, we have DE is parallel to AC. And it's also telling me that DE is half the length of AC, which is what we were noticing before. And we can use that information to find some missing side lengths in a question like example 1. So example 1 has a few things that we're trying to find. The first one is AC, and if I'm looking at this diagram over here, I'm noticing that AC is parallel with FD, and I don't know the length of AC, but I do know the length of FD. And because of our triangle midsegment theorem, I can say that AC is equal to 2 times the length of FD, or FD is equal to 1/2 AC. So I can replace FD with what I know it to equal, which is 6.2, which means that AC must be equal to, well, 6.2 times 2 is 12.4. So that is the length of AC. Next, it asks me to find the measure of angle CBD. So if I'm looking at this picture here, I'm noticing that angle CBD is forming alternate interior angles with the only angle that has a marked measurement. So what's happening here is I have AC is parallel to FD, and these parallel lines are cut by this transversal such that angle CBD is an alternate interior angle with angle FDB. So I can say, to solve that angle CBD is equal to the measure of angle FDB, and therefore is equal to 26 degrees. And I'll go ahead and rewrite that down here. So the measure of angle CBD is equal to 26 degrees. And if you were to forget why this is true, I would go ahead and write on the side that this is because of the alternate interior angles theorem. And I'm just going to mention too that you might not have recognized that that is happening, or that you have parallel lines, because we've been looking at parallel lines that have been horizontal or vertical. But parallel lines can go at an angle too, which is what we're working with now. So you do have to be looking carefully for those things. Next, we have BD. BD, if you look at the picture, is parallel to AE, and this is the midsegment, so that by our midsegment triangle theorem is half the length of the side it is opposite to, which is AE. So I can say that BD is equal to 1/2 AD, or AE, which is equal to 1/2 times 17. Half of 17 is 8.5, so BD must be equal to 8.5. Alright, last but not least, we have the measure of angle AFD. So I'm going to zoom in over here. I have AFD, and I'm not really noticing any information about these two angles that make up AFD, but I am noticing that I have parallel lines cut by a transversal, creating another set of alternate interior angles with this angle and this angle. So I know that angle DFE must be 26 degrees. And if those two angles have the same measurement, then I can use that information to find AFD, because this is a straight line, and we know part of it is 26 degrees, and the missing part is all that's left to find. So I can say that the measure of angle AFD is equal to 180 minus the measure of angle DFE, which is 26 degrees. 180 minus 26 is equal to 154, so I can say that the measure of angle AFD is equal to 154 degrees. And that is all we need to solve for this example, but there are a few other pieces you could find, because there's other sets of corresponding angles and other alternate interior angles, and a few other things as well, but we'll go ahead and leave it at that. So next we have the triangle inequality theorem. The triangle inequality theorem says that the sum of any two sides of a triangle must be greater than the third side. So AB plus BC must be greater than AC, BC plus AC must be greater than AB, and AC plus AB must be greater than BC. So let's go ahead and take a look at an example with that, because I think it's a little more practical to look at where you might be solving something with that. So example 2 says to determine if a triangle can have side lengths 3, 4, and 9, and explain why or why not. Well, by the triangle inequality theorem, 2 side lengths added together must be greater than the third. And if we're trying to figure out if they can form a triangle, you need to be working with the 2 smallest side lengths. If the 2 small side lengths added together are greater than the third, then it is a triangle. So I can say 3 plus 4, and that is equal to 7. Is 7 greater than 9? No. Because the answer is no, that means that this isn't a triangle. So the answer is no, and the reason why is because 3 plus 4 is not greater than 9. And this is your full answer, full sentence. You probably should also put the word because in there, but that is all I need. And I will also mention that if you don't like that this is not greater than, you could also write that this is less than, which would also be a true statement and would explain why these are not a triangle. Alright, let's take a look at a couple other examples. We have example 3 here that says determine if a triangle can have side lengths 5, 7, and 10. We're going to add those together. 5 and 7, they're the 2 smallest ones. 5 plus 7 is equal to 12. 12 is greater than 10, so the answer is yes, because 5 plus 7 is greater than 10. And that is our answer. Next, example 4. Determine if a triangle can have side lengths 6, 8, and 14. Explain why or why not. So I have 6 plus 8, which is equal to 14. So the answer is no, because 6 plus 8 is not greater than 14. It's equal to 14. But we can't have equal to 14. We can only have greater than 14. So therefore, not a triangle. Alright. And then next we have example 5, which works a little bit different, but it uses some of that same information. So example 5 says the lengths of 2 sides of a triangle are 8 and 13 inches. Find the range of possible lengths for the third side. Now, if we were to add these two things together, if they were the smallest side, that would tell us our capacity for the largest side, but we don't know if these two things are the smallest side lengths. So we have to account for if 8 and 13 are the 2 biggest side lengths, and we also have to account for if 8 and 13 are the smallest. So I'm going to start by adding 8 and 13. So 8 plus 13, 8 plus 3 is equal to 11. So we're at 21, and 13 minus 8 is equal to, let's see, 8 plus 2 is 10, plus 3, that'd be 5. So 8 plus 13 minus 8 is 5. So that means that our third side length has to be greater than 5, because 5 plus 8 is equal to 13, and if it's equal, it doesn't work. And it has to be less than 21, because 13 plus 8 is equal to 21, and this would have to be, the sum would have to be greater. So 21 is too big. So 5 is too small and 21 is too big. So our range would be 5 is less than x, which is less than 21. And that is your answer. So anytime you're asking for a range, you're going to add them together and put it less than that, and you're going to subtract them and put it greater than that. So we have 5 is less than x, which is less than 21. Okay, so not only can we figure out if our side lengths form a triangle, but we can also figure out which is greater or smaller using the information of only side lengths for angles, and for angles, or if we have angles, then we can figure out the side lengths. So what I'm really getting at is the angle-side relationships. Those are called Hinge Theorems. So we have this first theorem that says if 2 sides of a triangle are not congruent, then the larger angle is opposite the larger or the longer side. So I have AB, which is opposite of angle C, and BC, which is opposite of angle A. And if AB is greater than BC, then angle C is greater than angle A. And we also have, if 2 angles of a triangle are not congruent, then the longer side is opposite the larger angle. So I have XY opposite angle Z, and XZ opposite angle y. And if the measure of angle z is larger than the measure of angle y, then xy is greater than xz. So this all in theory might not make sense, but if you look at an example or if we write it in verbatim, then it might make a little more sense. So what's really happening is we're saying that the largest angle is opposite the longest side and the smallest angle is opposite the shortest side. So if we look at example 6, we know the side lengths, but we're trying to order the angles from smallest to largest. So if I start with my smallest side and I find the angle that's opposite of it, which is angle C, it's the only angle not touching it, then I can list my angles in order. So 7 is opposite angle C, so angle C is my smallest angle. Next I have 8, which is opposite of angle B. And I have my largest side, which is 9, which is opposite angle A. So my angles in order from smallest to largest are C, B, A. So that works if you are trying to figure out angles and you know the sides, but it also works the other way. So we're looking at example 7 now. That says list the side lengths in order from smallest to largest. If you notice here, I don't have any side length information, but I do know the measure of 2 of my angles. And you might be thinking, well, we can't do it because we don't know the third. But we do know that triangles have to have 180 degrees inside of their angles. If we know 2 of them, then we can figure out the third. So I have 180 degrees total, minus 61, minus 59. If you add those two things together, 61 and 59, that equals 120, which makes our subtraction really easy. 180 minus 120 is equal to 60. So our angle that's missing is 60 degrees. Alright, so now my smallest angle is 59 degrees, and that is opposite of side DE. So my smallest side is DE. Next I have 60 degrees, which is opposite of EF, so my second smallest side is EF. And then my largest angle is 61 degrees, which is opposite of FD, so my longest side is FD. Alright, that is where we are going to stop for today. We will go ahead and pick up in section 3 with some information about Pythagorean theorem, Pythagorean inequalities, and writing our answers in simplest radical form.